from Met Éireann, who's been a fantastic supporter of the DCU Water Institute, and she is speaking today at today's virtual Water Cafe, and she's going to talk about her topic is Be Summer Ready. But just to tell you a little bit about Evelyn, Evelyn is head of forecasting, the forecasting division in Met Éireann, and she joined Met Éireann as a trainee forecaster in 1981 after studying physics and maths in UCD. And she has thought about changing career, but hasn't done so yet. So Evelyn will talk to us now about...
That was a joke, by the way.
Yeah, I don't see anybody laughing, Evelyn. No, it's not funny. If you dare change career, I think Ireland would be disappointed.
It's a bit late now. It's a bit late now.
She's going to talk to us about how and why the National Meteorological Services now name storms and explain the yellow, orange, red warning codes. And I'm going to leave her now to speak about her topic, Be Summer Ready. Welcome, Evelyn, and thanks again.
Thanks very much, Fiona, and thanks, Ruth, for the lovely invitation. We met down in Cork.
Yeah, that's right. About 2 years ago, I think, at this stage.
Was it the Science, not Science Fest?
It was World Ocean Week, I think.
All right. So anyway, it's great. We're neighbours, and we're actually redoing our forecast office for the last few years. So when we get it up and running, hopefully later on in the year, we'll invite you over to have a look around. So maybe we'll do a little broadcasting there. But anyway, let's power on. On the 22nd of April, Minister Coveney, excuse me, I just had a little cup of coffee there. Minister Coveney launched the Be Summer Ready campaign, and this is a sister campaign of the Be Winter Ready campaign. Now, it might seem a bit extraordinary, you know, what do you need to be afraid of in the summer in Ireland, because we never get a summer, but there are certain issues, particularly, and this is where you guys come in, with water, because unfortunately a lot more people, there's a lot more fatalities in summertime due to weather-related incidences, and mostly around drownings, unfortunately. There are some fire incidences as well, and then obviously sunburn, which again, you know, you wouldn't imagine that that's a huge problem in Ireland, but unfortunately, cancer, skin cancer from sunburn is the third highest cancer rate in Ireland. So that's an unfortunate statistic. So you don't need, I think people associate skin cancer or skin damage with very high temperatures, but it's all about the angle of the sun. So I hope to show you a graphic later on if I can get down to it that far. But I really want to show you some of our website live as well, to show you some features. So I better motor on here. But this is myself and John Leach from Motor Safety Ireland and Gerard O'Flynn from the Coast Guard. And really, we were populating this Be Summer Ready leaflet, which is just a handy little reference point. I don't know if anyone reads these. I have 1,000 here next door, but of course nobody's out and about, so I don't know if anyone uses leaflets anymore, but it is nice to have a little summary ready. Now, Met Éireann, you recognise the building as your neighbour here, but we're a division of the Department of Housing, Local Government and Heritage, and our parent building is in the Custom House. And these are all our weather stations. Very few observers left at our stations at the moment. The only real live people are at the airports: Dublin Airport, Shannon Airport, Knock Airport, Cork Airport and Casement. All the rest are automatic stations. And we've some very good, we've over 100 automatic climate stations now, high quality stations. The blue ones here are actually over 500 rainfall stations, and these are still manned by voluntary observers. And Met Éireann are very proud of them and very grateful for their voluntary work. It really is citizen science, a very good example. And I know that DCU, your whole ethos there is in promoting citizen science. So we have these rainfall records going back over 100 years, and it's thanks to these that we've built up our rainfall chart, which I'll show to you in a moment. Now, Met Éireann is a small organisation. We have about 200 scientific staff, physics graduates, maths graduates. We allow in some engineers, some chemistry graduates. In our laboratory, we sample the air and we do ozone soundings and all that sort of thing. But we get our strength from our part in the international community led by WMO, the World Meteorological Organization. And some of you have probably heard of Ecmwf. That's the European Centre for Medium Range Weather Forecasting. And they run our global model. So I'll tell you about that in a minute. And EUMETSAT, that's the European Agency for Meteorological Satellites. And EUMETNET is the European Agency for Meteorological Services like Met Éireann. And I'll just move on there. So here's the satellite. Let's look at some weather. So this is the EUMETSAT, the Meteosat satellite, and the European Meteorological Satellite is situated over the equator. So here's the equator. It's very far down. Well, it's the equator. There's Lake Victoria here. And it's where the equator intersects the 0 line longitude. And the satellite is in geostationary orbit, 37,000 kilometers above this point here. And geostationary orbit means that it's orbiting with the Earth. So you know the Earth rotates once in 24 hours, so the satellite is moving with the Earth. So these are snapshots, and it takes these pictures every few minutes. And the white stuff here is the cloud. So you get the tropical thunderstorms moving westwards. Can you see the pointer okay? The red pointer, yeah. The tropical thunderstorms. Sorry, I'm from Laois, so I have a problem with my THs. The tropical thunderstorms move westwards under the easterly trade winds. And then sometimes at this time of year between June, the 1st of June is the beginning of the hurricane season, and it's the beginning of the Irish summer as well, the 1st of June. Now, I didn't say summer weather, I said beginning of the summer season. We define summer as June, July, and August because they are, in fact, the warmest months, but I didn't say they're the sunniest months. So sometimes these tropical thunderstorms spin into hurricanes and then get caught in our own jet stream and move back up across the Atlantic. And that's where Hurricane Ophelia came from, and Lorenzo and that sort of thing. Now, here's that map of Ireland I was talking about earlier. In fact, you could be forgiven for thinking it's a map of our mountains, an orographic map, but in fact it's a precipitation map. It's a map of our rainfall. And that's because, as you might remember from your geography at school, that's orographic precipitation. The moisture-laden air moves in from the Atlantic and hits the mountain, hits the McGillicuddy Reeks. It can't go through the mountain, so it rises up. And it rises up, the temperature decreases with height. You know, there's snow on top of a mountain. It's colder up on top of a mountain than at the base of a mountain. And so the water precipitates out. So you get rain on the windward side of a mountain. On the other side, you get a so-called rain shadow. So it's quite problematic actually when we're issuing a national forecast, because we have a forecast of rain spreading in from the Atlantic, heavy rain. But then if you live on the other side of the morning, say, on the mountains, say, what the hell are Met Éireann talking about? It's a lovely fine day, but all the rain has fallen out on the western side of the mountain. And we have that rain effect shadow here in Dublin, actually. Dublin is one of the driest parts of the country, but not today, and that's because the front is out in the Irish Sea and the wind is actually more northerly, actually. But a lot of the time, the rain precipitates out over the Wicklow Mountains. So Dublin is one of the sunniest parts of the country. But our friends in the West hate us saying that, so we don't advertise that too much. As our planet warms, so does our atmosphere. Warmer air can hold more moisture, or in fact, quite simply, if the sea is warmer, you get more evaporation as well from the sea. So in Ireland, we have seen an increase in average annual rainfall by about 6% over the last 30 years. Now, it doesn't seem terribly much, but in 30 years, it is significant. And we know this because, if you like, going back to all our observations, all our weather stations, and these are going back 100 years. So these are high quality measurements. So that's how Met Éireann is the holder of all the meteorological information for Ireland. So that's how we know. And this is for the years so far. Look, you have the slides, so please feel free to share them. This is January. This is just a typical figure for Ireland. January, the rainfall was 116% of average. February 136%, March 88%. It was dry, but extremely dry in April, 33%. And May so far, May's nearly over, it's 144. We'll say it'd be about 150% of average. But I think May really and April have been characterized by very cold weather as well. That often happens, that obviously when it's dry, it's cold, because when it's dry, you tend to get clear skies at night. And we did get a lot of frost, actually. We tend to be in sort of the northern air mass, the polar air mass. And again, I'll explain that in a moment. But in fact, some early sown crops actually got quite damaged from frost during April. Let's just move on now. Okay, there's a summary. We'll lose the will to live if we read that. But you can, as I said, you can email it and just read it yourselves. So as well as our rainfall stations, we've all these nice scientific instruments at all our stations around the country. Here's at our station in Valencia, and this is a weather balloon. So this augments information from satellite and from radar, from space. And actually, Met Éireann have a plan. We have 2 weather radars at the moment, but we've got clearance to establish 5 new weather radars. So it's just a matter of getting the sites, and that might prove fun. You know, as the rumor mongers and the conspiracy theorists get going about the dangers of weather radar, but there are none, of course. So we'll be looking to set up 5 new radars in the next number of years. Starting with this year, we're replacing the Shannon radar. So that's really an exciting development for Met Éireann. As well as that, we have the buoys at sea, and the network of 5 offshore weather observing marine buoys around Ireland is managed by the Marine Institute in collaboration with Met Éireann and funded by the Department of Agriculture, Food and the Marine. So here are the weather buoys. Now, so this is all feeding into the WMO, the World Meteorological Organization Climate Observation Network, with over 10,000 surface weather stations, 1,000 upper air stations. Now, an upper air station isn't a weather station in space. It refers to these weather balloons, which we send up twice a day. But in fact, over the last year, during the COVID shutdown, when there's been very little flights, in fact, that has reduced the information into our weather models. So the National Meteorological Services sent up additional weather balloons to augment the information that we were missing from the aircraft. So that's just a little aside there that's interesting. Now, how do we forecast the weather? Well, in the olden days, in the pre-scientific era, I mean, obviously it was very difficult. It's very difficult now, but in the pre-scientific era, I mean, people looked for signs from nature and tried to sort of look for patterns. But now, of course, we use weather models, and we basically model the physical processes in the atmosphere. The weather takes place in a very thin layer of the atmosphere known as the troposphere, which is only about 11 kilometers above. If you had a peach, if the Earth was a peach, the part of the system that produced the weather is really about the skin of that peach. That's how thin the atmosphere. Between us and oblivion is about 10 kilometers, which is very, very little. If you think that the weather satellite, as I said, is orbiting 37,000 kilometers above the Earth, I mean, the actual layer of above the Earth that produces the weather and the air that we breathe, and really, without this, we wouldn't exist. There's no atmosphere on the moon. On the Earth, the troposphere, which produces our weather, and the air that we breathe, as I said, is only about 10, at the most 14 kilometers in height. So anyway, we model the physical processes of the atmosphere. The Earth moves around the sun once a year. It spins on its axis every 24 hours. And we use then the equations of the atmosphere, the so-called primitive equations, although they're not very primitive, really, they're very complicated. So, but we all remember Boyle's law and Charles's law from school. And Boyle's law, PV equals a constant. If you, for example, if you pump air into a bicycle tire, it gets warm. So that's, you've increased the pressure. It's a limited volume, so the temperature increases. So there's all these equations of motion, thermodynamics, etc. And that's why meteorologists come from this discipline, and our modelers come from this discipline, because meteorology is the physics of the atmosphere. Now, the early days, when I joined Met Éireann first, really models were in their infancy. And what we do is we sort of break up the Earth atmosphere, troposphere, into little blocks, if you like. You can think of it like that. So the very early models. So if you go back to our weather stations, we, you know, as we saw there, the WMO, let's say we have 10,000 weather stations around the Earth. Okay, that is a lot, but it's nothing if you compare that every atmosphere, or every molecule in the atmosphere, if you like, is its own mini weather system. Because what is temperature? Temperature is basically the kinetic energy of a molecule. So when we measure temperature with a thermometer, that's just the average kinetic energy of all the molecules hitting off that thermometer. So we have to model the weather. And so the early models, if you like, had two squares, or we call them cubes really, weather is three-dimensional, two cubes over Éireann. So that was a very primitive 125 kilometers resolution. What that means is each side of the cube is 125 kilometers. So as models increase in complexity, so too does its representation of Ireland and the countries. So I want to explain a bit. There's been a lot in the media recently about weather apps. Now here's the Ecmwf global model. Now this is the best global model in the world, the European Centre for Medium Range Weather Forecasting. And Ireland is a part of that, obviously. And this global model used a 9-kilometer resolution. So you can see Ireland is modeled pretty well. If you go back to the earlier ones, you know, it's pretty good. So the weather apps that we buy in our phones are actually can be a lot worse than this, can only be say 25 kilometers or whatever, less than this. Or so they are an approximation. But the Met Éireann app and the Met Éireann model, we have a resolution on a model of 2.5 kilometers resolution. So you can see that the mountains, and you see the Wicklow Mountains and all the other mountains, are modelled pretty well, and the rivers around Ireland. So that's why each National Met Service, we put our money into funding the observations. You need high quality observations. Obviously you need an analysis of the observations, and that's the climate section. But into the forecasting section, we put our money into developing our own National Meteorological Service model, high resolution model. So Ireland has this for Ireland. France has its own high resolution model. I mean, we're not paying for France's model, and they don't pay for our high resolution model. Now we are moving into a consortium of high resolution models for Northern Europe, and maybe in a few years' time you'll hear more about that, but we're channeling our energy into that at the moment. But a very exciting development are our ensemble system. Now this is, I won't say it's complicated, but it takes a little bit of time to explain, so I'm just going to run through it. But you know, a musical ensemble consists of different musicians. So we run an ensemble system of forecasting. So if you like the picture we showed, the isobars that we show on the TV at night, that's called the deterministic output. So it's one run of the model. So what we do is we perturb the initial conditions. If you like, we build up the initial conditions, the initial picture. You can hear more about this on our podcast, actually, if you go on our website. It'd be explained much better than me. But we really run the model 11 different times with different initial conditions, and we can get 11 different outputs. The red area here, this is for one moment in time, is where storm force winds are predicted. So you can see the forecaster is faced with some solutions here that give no storm and some that do. So when we issue our warnings, we have to take all this into account. So it's not just we look at one solution from the model. So this is our high resolution model. And indeed with the European, we have 50 different solutions. So as I said, if you go on, you can hear all about this on our fantastic podcast series. And we're delighted that RT are co-producing these podcasts with us now over the past few months. Now, as well as the Be Summer launch, we launched in the afternoon of the 21st of April our new marine warnings. And I'd rather show you these on our website now, but you can sign up for 3-day marine weather warnings. And also you can get fantastic information now on our website. If you zoom in for the Atlantic picture, and also it's hard to see the colors here, but this is Cork Harbour for 10 days. 7 to 10 days ahead, you can get the wind information. And also, if you go into our marine section for lakes in Ireland, 7-day forecasts, and also for the islands around Ireland. So, and also the sea temperatures. So this is why, I suppose, for the Water Cafe, I want to give you our new products for marine and for the waterways on Ireland. So again, I'll show this to you on our website, but here's the lakes in Ireland. And if you click on this, and if you notice your favorite lake or your local lake is missing, just email me and I'll add it to the list. And the same with the islands. So here's the sea temperatures, and it's a 5-day sea forecast, and also the waves around our shores. Now, a little bit about, Fiona mentioned earlier about the color coding of our warnings. And I think you're all familiar now with the yellow, status orange, and status red. And the forecast really bases the issuance of these warnings on a certain criteria, and they're here and we'll share them with you, but they're also obviously on our website and app. But we're moving towards, it's goal 1 actually in our 10-year strategy, to enhance support for impact-based decision-making for weather events. So this is where National Met Services are moving towards now. It's a very exciting development, but I mean, it's not that we have, we've nailed down the forecasting end, but there's been huge improvements. There really has been a quiet revolution in forecasting, not only in my lifetime, but certainly even in the last 10 years. And that's due to these new high resolution models on the Ensemble forecasting. We can have reasonable amount of confidence in 2 to 3 days ahead that we're going to get. I mean, if you look at the size of Ireland and the size of the Atlantic, I mean, it's a fantastic feat that their models are able to track weather systems moving 3,000 miles away and track it in 3 or 4 days ahead and be fairly precise where it's going to hit. So that's a fantastic revolution in weather forecasting. But our next step now is to relate the actual weather conditions, the wind strength, the amount of rain to actual impacts. So this is a picture of the ploughing championships that I took myself. And in fact, the winds on that morning were, if you like, yellow level. They were about 90 to 100 kilometers per hour. But of course, we upped our warning to orange to account for possible orange impacts, as there were there were thousands and thousands of people traveling from all over the country. And obviously it was closed down on the morning ahead of the storm. It was quite nerve-wracking for me predicting that, because I had to stay down with the ploughing people, and at 6 a.m. in the morning, it was flat calm. It literally was the calm before the storm. So the meeting with the ploughing people and the Gardaí that morning, I said, where is the wind? I said, well, it is coming. So like the life of a weather forecaster, even though the modelling has improved a lot, it's still very, very stressful. And I've just come from a meeting with the heads of forecasting in Europe just before this meeting here. And, you know, sort of, in a way, I'll talk to you in a minute about storm naming, but storm naming has really caught on. Obviously with the media, love it because they love anything to make a fuss. But if we issue the warnings 3 days ahead, then, you know, the big media, and I don't mean to say circus, but like it can be a little overwhelming. So we're waiting there for the forecast, which is a scientific forecast, to work out. So nothing is definite until it actually happens. But, you know, thankfully models have improved a lot. So we are getting a lot more hits than misses. And that's why we feel confident now of issuing warnings about 3 days ahead. So we're working now, enhancing support for impact-based decision making. Is this rainfall going to result in flooding? Is this wind going to result in trees being uprooted? So that's where we're moving ahead. And in fact, you mentioned there, I think, Fiona, about that's one good thing. You know, we're having this meeting by remote, but Met Éireann are now briefing our stakeholders remotely, and it's proving very good. Here's one we had with a summer storm last year, I think Storm Ellen. We briefed the local authorities, and in fact earlier this year we had 350 of our stakeholders being briefed directly by the forecaster from the forecast office. So, you know, we all learned quickly how to do this, so that has been a very positive development. Now here's the storm names for this year, and it's been a very quiet year. The only one actually Met Éireann named was Storm Aidan. And this is a young boy, Aidan de Rochta, who was very happy that the storm was named after him. It was a Halloween storm, and I produced some. If you click onto that Twitter feed there, I'm not going to even try and show it. I can just barely share the screen here, so I won't tempt fate. But if you click onto that yourself, or maybe Ruth could show it to us at the end of this meeting here. So it was a minor storm in terms of how far it affected, but it did cause some damage and disruption in the northwest. And there was a squall line associated with it, which actually caused quite a lot of trees down over the Midlands, which the winds there were about 100 kilometers per hour, but it was an intense squall line with thunderstorms, and that caused a lot of damage. So, like, in a way, the media always highlight winds. It's, you know, you don't actually need the high winds. They kind of say, oh, are the winds only going to be 100? But that's not necessarily the extent of the damage. So that's why Met Éireann and forecast offices are trying to relate more, trying to predict more the impacts than we have the amounts, the intensity, if you like, nailed down. So now we're trying to move into predicting the impacts. And for example, our colleagues in storm naming in KNMI, they actually named a storm for its snow impacts rather than its wind. And that gave widespread snow over Holland. And again, I've just come off a meeting with them. And for England, the Eastern England, and of course, this happened in February, and it caused widespread transport disruption power and had a huge impact because the vaccination and testing centres, a lot of those were situated outdoors in tents. So, you know, this was a high impact, and the chief forecasters in Holland and England, luckily Ireland escaped from this, you know, were briefing the government. So, and this was predicted 4 to 5 days ahead. So we can see what a huge impact, we can see what a huge impact that these storms had and these high impact weather situations. Now, the reason National Met Services name storms is for reach, engagement and influence for our warnings. And this has certainly happened. And in fact, in a way too much, because as I said, the media do love it. And we're very grateful that they do share our message and share our warnings, because when the National Met Service names a storm and issues warnings, you have the authoritative voice of that National Met Service. It's not just anyone or an agency or some other agency issuing the names. It's important that the National Met Service does so. It fosters communication and really also collaboration. NMS, we're terrible for acronyms here in Met Éireann, like it's just a nightmare when you join Met Éireann first. NMS means National Met Service. So because we are in collaboration with the Dutch Met Service and the British Met Service, then we physically ring, which is we find the handiest to discuss, well, we're thinking of naming this, and you know, we're all able to share our modeling or whatever. So it has fostered communication between the chief forecasters, and of course it's very useful for reference for writing reports, etc. And very briefly, we only name storms for large depressions and not for local winds, sort of Bora Bora or phone effect winds. In the continent, this is especially important because you can get hurricane force winds with funneling down between the large mountains in the Alps and that abroad. And it's based on warnings in orange warnings or red warnings. And the National Met Service, which first issues the warning, names the storm. And the whole idea is that we want, when a national Met Service, or that's the National Hurricane Center in Miami, when we name a storm, that the National Met Service keeps that name and that the media use that name. And it's in conjunction with weather warnings. We just don't name a storm for the fun of it. Like there's hundreds of storms off the west coast of Ireland every year, but we don't name those. It's only if we're expecting impacts over land. And it has a huge engagement through social media. And obviously our social media impact here, this is our hits on our website. So it's all for the storm names, look. And that's augmented by our forecasters on TV. And we're very grateful to RT Television to continuing our collaboration with them. Since the first day of television on 1962, the 1st of January, there's been a Met Éireann weather forecaster telling the weather on RT. So we're delighted that that continues. So while our message is continuing to get across on social media, it's still very powerful on the 9 o'clock news at night. Now, very briefly now, we saw this satellite image before. We have tropical storms at the tropic where sea temperatures can be in excess of 30 degrees. Hard to imagine, like it's about 12 degrees in Dublin today. So you get evaporation from the ocean. So tropical storms and hurricanes are fueled mainly by convective processes, evaporation from the hot seas, whereas at our latitudes, the mid-latitude storms are fueled by the clash between polar air and tropical air. And the clash zone is known as a weather front. And that weather front was described by the early pioneering meteorologists in Norway in the early 1900s. And they likened to the Western Front in the First World War, but the front was the dividing line, the clash zone between the two armies. So a weather front is really an area of rain where the polar air hits the tropical air. And the reason it was so cold in March and April is we were on the cold side of the weather front a lot of the time, and we had all these showers of hail and some snow around as well. What we really want for a warm summer is to be on the warm side of the polar front. So that's what we're hoping anyway. But of course, for people in Irish water, you don't want a long hot summer because it'll lead to drought and water shortages. So I guess ideally we'd all have rain at night and then nice sunny days. I think that's what we'd all like. But sometimes people would say, gosh, in Met Éireann, you really are hedging your bets, like by talking about rain clearing to showers, but they're completely different weather. So rain is this frontal band of low cloud mist stratus, whereas showers, you've heard that phrase, sunshine and showers. And the reason we use cliches is because they do work. So some of you are familiar with cumulus. Some of you are young enough to remember the Teletubbies, and you're all familiar with the Simpsons. They're these little puffy clouds. They're cumulus clouds, but they grow up into cumulonimbus. Nimbus is the Latin for rain, and cumulus is the Latin for heat. So when it builds up and up and up into violent thunderstorms, and here, I think it's good to kind of be familiar with clouds. So here's a thunderstorm and hail. And in fact, hail showers can cause, unfortunately, and have caused fatalities on our motorways, because you have lovely blue sky and suddenly a shower moves in, develops nearby over a lake or whatever, and moves across the motorway. And you get this violent thunderstorm. Well, not violent by international standards, but by Irish standards. And you get this sudden hailstorm. And the traffic doesn't slow down, and it really compacts the ice. And there have been quite a few fatalities on our motorways. And that's why you see now TI are putting out warnings for hailstorms. And Met Éireann are working with them on this. And on the other side here, we've got the nimbus stratus, that's the frontal cloud. So the low clouds, for hill walking and that, this is very dangerous. So we're warning people really to be aware. If you hear the Met Éireann forecast talking about, especially in Dublin and for the Wicklow Mountains, it can be a sunny start to the day, and then the front is moving in, well, from the west, from the Atlantic. So the same can be true in Connemara. It'd be beautiful and sunny, but then suddenly the cloud lowers and you get the front moving in from the Atlantic. And literally what as low cloud and stratus covers the mountain. That's basically fog and visibility is 0. So it's very dangerous indeed. But of course, we are looking for some nice sunshine this summer. And Met Éireann are working with the HSE. They have a fantastic video out. I'm not going to try and show you because I don't know how to show videos, but they'll be launching that on the 1st of June. Summer starts officially on the 1st of June. But I just want to show what this is. So the UV index peaks at high noon, and high noon in Dublin is actually local time of 1:20. So Greenwich, noon Greenwich is over Greenwich, right? Now, I need you to think about this. So the Earth rotates through 360 degrees in 24 hours. Look, you can think about it afterwards, but I'm just throwing it out there. So Ireland, Dublin is about 5 degrees west. And if you like, Clifton or Galway is about 10 degrees west. So 15 degrees of movement is equivalent to 1 hour. Anyway, so noon Greenwich is 1 p.m. local, and then you've another 20 minutes. So high noon in Dublin is actually 1:20 local, and high noon on the west coast is 1:20 local. So in fact, the burn time, high burn time is around high noon, which is, you know, 1:30, we'll say, in Ireland. So the high burn times, that's what we're saying, say for the months of June and July in particular, that you can actually burn between 11 a.m. and 3 p.m. in the afternoon. Whereas the temperature doesn't peak here until later on in the afternoon, which is about 3 o'clock, or on a hot summer's day, maybe 4 o'clock, you get the maximum temperature. So I think that's enough. I'm saying here, have a nice, safe summer. Do you want to, if anyone wants to ask questions? Hi, everybody.
I have loads of questions, Evelyn. And first of all, can we give Evelyn a kind of virtual clap, or if you want to turn on your microphones and clap really, because that was super. I'm just bursting. I love clouds. I actually spend my head looking up at clouds. I love them so much. So that little slide that you had there with all the cloud types.
Caroline, how are you, Caroline?
Loved it.
Actually, Caroline, we're delighted to be working with Caroline in DCU there, Caroline McMullen.
Yeah.
And maybe do you want to say 1 or 2 words, Caroline, about you're doing this fantastic project for us?
Oh dear, I'm sorry, Fiona. I hope you don't mind me jumping in.
Delighted, Caroline, and lovely to see you. Yeah.
No, we're really delighted. We're working through an IRC project with Evelyn and with Met Éireann, and we're looking at the future. What do we need? What do Irish people want from Irish weather forecasting services, climate change information, and also then to look at how we view the risk associated with weather, how prepared families and households are. And it's been really exciting. We're coming towards the end of our first major report, and we have been holding focus groups all across the country with people, asking them what could we do better, and reviewing the app and the website and all of those things. So it's been really exciting, and we've absolutely loved it. So thank you. And I loved this morning. Thanks, Fiona. I always love hearing from you and the Water Institute, and great presentation today.
Thanks, Caroline. I'm going to be back in touch with you. I didn't realise you were doing all that. That's brilliant. Lovely to see you. But there are loads of other questions as well, and we have maybe about 5 or 7 minutes to go through them, if I can, Evelyn, if that's okay. First question here is, do you set scenarios for the beautiful slide you had on the ensemble? Do you set scenarios for each of those different graphs that you showed? Is that how you get the different responses?
Okay, now I'm just putting up our website there. That's a really good question, and maybe some other time you might get one of our modelers to talk to you, because they're especially say Dr. Alan Halley, he's starting to work as an impact meteorologist, but he is a modeler as well. But what they do is they perturb the initial conditions. The computer does, if you like. I'm not sure how they do it on a day-to-day basis, but I think that it's a lot of automatic, like we change the pressure slightly, or we change the temperature slightly in the initial conditions. Like the forecaster doesn't sit and change it. This is all done by the modelers, but I think a lot of it is done automatically. I mean, with the European model, where we 50 ensemble members, I think, you know, that's slightly different because there's a huge gap in our knowledge, say, over the Pacific and over the southern hemisphere. There's very few weather stations. I mean, most of the people, if you look at a globe, like if you look at the Pacific, well, you know, that view from the other side of the globe, I mean, it's mostly water. So most people and most of our weather stations are in the northern hemisphere, but you know, we do perturb the initial conditions. So actually, if you want to go onto I'm trying to pass over that, you want to go onto our podcasts, keep asking questions there, and I'm just going to.
Yeah, there's loads of questions here, Evelyn, and we might have to send them on. Just want to ask you, do people use your products for developing apps for things like leisure sports? Stand-up paddle boarding is really popular now. Do people ask you for data for those? Just
yeah, now we have total open data.
Oh, great. Okay. Yeah.
So if I can see it now, science. Oh God, it's terrible doing things live. I don't know where it is.
Yeah, no, don't worry. I mean,
open data policy. So you can pull in the API and we welcome it. And we have, oh, here it is here, open data.
Wow.
And totally on Met services, because that's our job. We want to spread a high quality information, and you can totally use, and all our stipulation is when you use our weather warnings that you don't interfere with them, obviously. And also widgets. Keep going, get more.
I'm going to ask another question. Somebody who's listening here, did I understand that there were other factors apart from speed that make high winds dangerous, and what are they?
There's open data, and you can put widgets. I'd love if you put all on your websites. We have warning widgets or whatever. It's totally free. Like use it, and you can put it in for, say, Dublin. You can put it in for Wexford. You can put it in for your own local area, and you can get a localized forecast. Like, it's all there. It's just I'm trying to spread the word. What was your question?
Yeah, in relation to wind.
Oh yeah. Well, it's actually quite, well, I won't say complex. Well, there's a whole lot of different factors. So, for example, we could get an orange level, like really bad winds, and the tree outside your door, you know, won't budge. But then 3 days later or 6 months later, there could be a much smaller wind, but the first storm would have weakened it.
Yeah.
So the second one would have the effect. Now, there's no way as a weather forecaster I can tell you about that, but the local authority, that's why, as we said, and that's why we're working with Caroline to get the messaging across and be aware of sort of our warnings and the factors that can lead to the impact. So
it is
very complicated.
That's an interesting point, that, you know, it can have done some damage earlier and it might take something lesser of an impact to have.
Yeah, I'm going to just show you, keep talking there. I'm just going to show you the islands. For
somebody just commented here, it's very interesting about high noon. Great.
Oh yeah. So those of you heading west, you can pick out your island, and you can see that we have 7-day forecasts here, so people aren't really aware of this. And in case you don't know where you're going, look, it shows up on the website here. And
there's a great question here, Evelyn, from Elena, who asks, do models integrate any soil measurements or parameters? And don't you think that there should be better integration between observations of the three main compartments, water, air and soil, into weather models?
Oh, they are. Oh, absolutely they are. Oh yeah, we are. And we have two of our PhDs are actually, they've modelled in the boglands in Ireland, and obviously, you know, I mean, in my day, models have become fantastic, no thanks to me, but I can't even imagine what's going to happen in the next 30 years. I mean, my successor will be talking to your successors here saying, oh my God, imagine they only had 10 ensemble members. I mean, I'm saying when I started in we didn't have models. The new forecasters now say, you know, like we didn't even have computers in 1981 or the internet. So
can I ask you a question, just, and we'll finish on this, is that what I'm getting from this presentation is that it's very impressive how Met Éireann collaborates with everybody. Is it a feature of the agency, or is there some other driver that means that you collaborate with the HSE, with the EPA, with Irish, with all of the other groups that you've mentioned? Is it driven by the Met Éireann itself, or is that something that is, defined by policy?
It's in our strategy, our 10-year strategy, because we could have all these fantastic forecasts, but they're no bloody use for ourselves. Our job is to share our knowledge and to help the citizen, and I could have the perfect forecast, but if nobody hears about it, it's no use. So yeah, we want to collaborate. We want to give our messages, because we learn from our stakeholders. We've learned that there's no point in just saying there's going to be 20 millimeters of rain. That's kind of useless information. We want to know what the impact is. So it's all here in our strategy. And if anybody wants to collaborate or talk to us, please come to us.
I think that's a great place to stop, that you want to collaborate and you want to have impact. That's a great endpoint. And certainly you've had an impact on me this morning. I love hearing you speak and appreciate so much. And if everybody could just give a thumbs up or a big clap, turn on your mics and yell. Thank you so much, Evelyn, for your time this morning. I hope you had time to have your coffee as well.
No, I have to. Sorry, can I just say, summer starts on Monday or Tuesday. As I said, it's not summer weather, but we've just introduced a new monthly forecast. Caroline will freak here. I don't know how we're going to verify this, but it was an experimental product like 3 years ago, so we have some confidence in it now. But we'll be updated. We update this every Tuesday and Friday. So wait until this afternoon, and you should have some improvement here for some idea of what we expect for June. Okay.
Brilliant.
Thank you so much.
Thank you so much.
Thank you. Thanks, Evelyn.
Thank you very much. Thanks to everybody who joined us today. Stay safe. Have a lovely warm weekend. The weather's going to be great, apparently. So take care. Stay safe.
Thank you. Bye.
Outlook there. High pressure that Azores High is forecast program. Woo! Yoo-hoo!
Get the barbecues out, yeah.
And be very careful, don't burn in the sun, water safety, and for Irish water, look, we're due a bit of fine weather. I know we don't want a drought. Okay, bye everybody. Bye-bye.
Thanks again.
Thank you so much.